Now that we have a basic introduction to theoretical probabilities, we are ready to start talking about combining probabilities using words like and, or at least once. And so this next video is going to be focusing on and probabilities. But before we're ready to look at and probabilities, we need a couple of definitions. And so the first definition here, we're told that two events are considered to be independent events if the outcome of one event does not affect the outcome of another event. So maybe I had a classroom full of students and I had a deck of cards and I kind of fanned those cards out and I walked up to a student and asked them to pick a card, and I wanted the probability of that student drawing a queen, since we looked at that in the previous section. Then we know the probability of that person drawing a queen would be 4 out of 52. And suppose that I returned that card back into the deck, and then I walked up to another student and I still had 52 cards again, all 52 cards, and I asked them to pick a card, and I wanted the probability that they would draw a queen. Those two events are going to be considered independent events, and that's because whether or not the first person gets a queen has no effect on whether or not the second person does, because that queen was returned to the deck. The other definition then is dependent, and so we're told that two events are going to be considered dependent events if the outcome of the first event affects the probability of the second event. And so if we go back to that deck of cards example, and suppose I have a deck again of 52 cards and I fan those out and I offer them up to a student and ask them to pick one of those cards, and we want the probability of a queen. Again, the probability of drawing a queen would still be 4 out of 52. But if I have that student, whatever card they draw, if I have them keep that card and then go on to another student, and at this point I only have 51 cards in the deck, and I want to figure out the probability of that next student drawing a queen, their probability is going to be dependent upon what happened with the first student, whether or not the first student drew a queen. And if the first student drew a queen, there's only 3 queens left out of 51. But if the first student did not draw a queen, then there are still 4 queens left out of 51. And so you can see how those events would be dependent events. So the reason that matters is that when we're calculating and probabilities, we have to consider whether or not our events are independent. And so we're going to look at an example here where it says we're going to flip a coin 2 separate times. And what we're asked is, does the outcome of the first flip, being heads or tails, have any effect on the outcome of the second flip, being heads or tails? And since the answer is no, flipping a coin 2 times consists of 2 independent events. And when we have independent events, the probability of event A and event B both occurring is going to be the product of the 2 individual probabilities. And you can extend this to multiple events as well. So for this example, if we wanted the probability of flipping a coin 2 times and having it land on heads for the first flip and heads for the second flip, so the probability of heads on the first and heads on the second, because those are independent events, that's just going to be the probability that I get heads on the first flip multiplied by the probability that I get heads on the second flip. So on the first flip, there are 2 possible outcomes, heads or tails, and there is 1 way to get ahead. So probability is 1 out of 2. And then on the second flip, the probability is still 1 out of 2. There's still 2 options, heads or tails, and there's still 1 way to get ahead. And so that probability is 1/2 times 1/2, which is 1/4. Just to visualize here what's going on, I'm flipping a coin twice. And so the first time it could be tails or heads. And then the second time, whether I got tails or heads, I still need to flip again. And I could get, again, tails or heads on the second flip. And so what this does is it allows us to see our possible outcomes. So we could get 2 tails, we could get tails heads, we could get heads tails, or we could get heads heads. And so this is another way to visualize this probability. We wanted the probability of heads and heads again. And the only way that can happen is right here. There were 4 possible outcomes, and one of them is heads heads. So 1/4, you can see it there. Okay. So we're gonna do a few more of these probabilities. So this time we're gonna look at putting some different colored balls or marbles into a bag. And so it says, suppose I put 5 red balls and 5 black balls into a bag, and I'm interested in the outcome of drawing a red ball. Does the color of the ball I pull out first have any effect on the probability of the color of the ball I pull out second? And the answer there is yes, assuming that we pull one ball at a time without replacement, meaning once I pull a ball out, I do not replace it back into the bag. And so that's going to consist of dependent events. And in the case of dependent events, if we want the probability of A and B both occurring, so you'll notice this looked the same as it did before. It's still the probability of A and B, but the way we calculate it has changed because we have dependent events. And so we're going to use the probability of A, and instead of just multiplying by the probability of B, which we did with independent events, when we have dependent events, we multiply it by the probability of B, given that we know A has occurred. And so for this example, if we want the probability of drawing a red ball first and drawing another red ball second, that's going to be the probability of drawing a red ball on the first one times the probability of a red ball on the second, given that we know we drew a red ball on the first. So the probability of drawing a red ball on the first draw is going to be the number of ways to draw a red ball out of the total number of balls. So there were 5 red and 5 black in the bag for a total of 10. And 5 of those were red. So the probability of getting red on the first was 5 out of 10. And now what we want to do is we want to find the probability of getting red on the second, given that we know we already drew a red one. Well, there's now 1 fewer ball in the bag because we started with 10, but we pulled 1 out on the first draw. And we know that the first one was red, which means instead of 5 red balls remaining, there are only 4 red balls remaining. And so this probability is going to be 5 times 4 is 20, and 10 times 9 is 90. So this probability is going to be 2/9. Okay. So we're going to stop there, and the next video we'll start looking at OR probabilities.